Thank you. Thank you, Valerie. Appreciate you guys coming in today and spending a little time to discuss a couple topics. And as Valerie said, don't hesitate to ask questions. I hate when it turns into a monologue. I'd rather it be a discussion and you hear different insights into things. The topic that I want to talk about today is control system interoperability for system integration and energy cost reduction. And typically when you look at those two topics, it seems like they're totally distant, totally foreign. But actually what I want to try to do is show some case studies where we've used system integration that yielded energy management and cost reduction. And we'll talk about different aspects of both as we move forward. But again, don't hesitate to ask a question, throw your hand up, or just speak out. So, obviously there's benefits to interoperability of building automation systems. But a lot of people view those benefits as solely being, controller to controller. There's other intelligent building systems in the building, of course, and so we view integration as working with all those intelligent systems and bringing them into one usable front end for the building manager. So other systems in there, of course, CCTV, and we see some iframe integration where we're streaming a closed circuit TV feed into a web-based front end that's looking at the energy management system of the building. And of course, talking with generators, intelligent power meters, a whole host of different intelligent devices in the building, not just other VAV controllers or other packaging controllers. So the benefit is bringing all that into typically one common web portal for use for the facility managers. And it also extends legacy systems in a building. Buildings expand and grow all the time, so a lot of times, unfortunately, there's obsolescence of those systems or those protocols go out of date. I was talking with a couple people earlier and they've got that problem where they're trying to talk with a whole bunch of legacy systems throughout a network. So interoperability helps get the extended life out of those legacy systems to where we can bring those into a modern web platform. And of course, open systems and flexibility for sourcing. You can buy drives from a whole host of sources, controllers from a host of sources, generators. So again, that interoperability brings a lot of things to the table. And there's actually many more that we could drill down to, but those are some of the highlight benefits of being able to integrate systems into one common platform. Typical standards that we see, and most everybody's familiar with all these that I have listed up there, and again, there's even more, but these are the more common ones. And there's, we're all in the HVAC industry from my point of view, and you guys are in the building management industry. But then there's typical standards such as BACnet, which is an ASHRAE standard for sharing data, and there's a couple ways that it is implemented through MSTP, Master Slave Token Passing, or IP. And then there's standards that have been borrowed from other industries such as Modbus and OPC, and they're just interoperability standards that came out of the industrial automation world. And an example, Modbus is a controller level protocol that's been around for quite some time. A lot of industrial pieces like generators and power meters and VFDs have used that for 20 plus years. OPC is again another method of sharing data at a software level. We'll talk a little bit more about that, but that comes from the industrial world as well. And then some higher level methods of sharing data through open database connectivity, common data structures, CSV, data export, import, at Modbus, Obix, Echelon Corporation, LawnWorks, using Niagara AX framework. So, and we'll kind of use all of these methods in some of these case studies. I got 6 small case studies that we'll run through, and you'll see how we integrate the systems at various levels. So typically you've got, controller or hardware level integration. It's where, where the control device has a data value it needs to share with somebody else. So those are typically shared on what's known as an RS-485 network. And there's a lot of acronyms in our system, as you'll see in our industry, and I'll try to explain some of those. But all an RS-485 network is twisted pair of wire. It's a communication network. And so think of a RS-485 network kind of as a tongue. Everybody has a tongue, they all communicate with the tongue, but this tongue might speak a different language from this tongue. So interoperability is basically taking those communication signals on that wired network, that RS-485 network, and being able to use those to share data. So the language in this instance You know, the 485 is the tongue, the language is what we refer to as the protocol, the communication protocol. So again, we're going to use an industry standard protocol, BACnet MSTP, and also Modbus RTU, and those are all RS-485 or controller level protocols, as well as LAN by the Echelon Corporation, which is an open network that's accepted widely in our industry as well. Those can all be communicated with JASIC Open Systems, and we'll expand on that in a little bit. But those are all, like I said, controller level. Then we look at front-end intelligent building system levels, network levels, and here's where we run into a whole host of acronyms. Native OPC, and again, that was borrowed from the industrial automation world. It's actually an acronym that stands for Object Linking and Embedding, or OLE, for process control. And everybody's heard of Allen Bradley and Yokogawa and Mitsubishi PLCs, and they do robotics control, and they share data at high data exchange rates. That's the technology that they use to share data between Rockwell or Mitsubishi. So it's used in our industry to read other data values from industrial applications that may end up in a building. And so again, we're talking about higher level architecture interoperability here. ODBC, another acronym, Open Database Connectivity. And what that is just being able to read and write data from a SQL data structure database, such as Crystal Reports, Microsoft Access. So you might use some of that software in your building, and there's things that you want to either bring into it, right, or read out of the front end and share that with your control system. So we have the ability to do that too. And then common exports, comma separated variable files, CSV exports. That's how we can take data that we trend from the control system and export that into, say, an Excel spreadsheet or something that you need to look at your energy uses versus outside air temperature or something of that nature. So, and then legacy drivers to talk to, as I mentioned earlier, older control systems that the protocols maybe have become obsolete. So we can use building automation system drivers. And there's a host of methods of doing that we'll talk about. And then of course OBIX, which is just a standard of sharing data through front ends that's based on XML, and we'll touch base on that. So again, the point of this slide is just to drive home there's a couple variable levels of interoperability and sharing data between systems. And again, don't hesitate to ask questions. There's a ton of these acronyms and concepts here. Okay, so the most common method that you see today is Tritium. And Tritium's evolving and changing, but it's been around for probably how many years now, Guy?
97 was when they launched, but
97.
99 was when they went to full.
So quite a few years. It's become almost the default interoperability solution, and it's at the front end level, the software or the user interface level. And of course, we're ASI controls and the JACE, the Java Application Control Engine, is what Tritium uses to share data, read different protocols. So our marketing people came up with this fancy term, the JASIC. So that's just an ASI specific term, but everybody's heard of a JACE here, right? And sharing data with JACE. So this is again going to be a front end level. It's the most widely accepted method in our industry today to share information. And it practices a lot of those methods we just discussed at the higher end, front end level. And it also, while we're moving into the BACnet environment, there are certifications. There's BTL, which is BACnet Testing Laboratories. That's a group put together by BACnet International just to make sure my BACnet device talks to your BACnet device. So it offers a BTL certified operator workstation and advanced workstation. That's what those acronyms stand for. And what that means to you is it's going to be a certifiable front end that allows you to look at brand A, B, C, D, whatever the case may be, through one common front end, and it verifies that it's going to work. And these guys—
As long as it's BTL.
Yeah, yeah. These guys here at Design Mechanical use this, and they're proficient at pulling in data from, again, not just HVAC systems, but other intelligent building systems through this method. And there is actually, these are for smaller distributed embedded web-based front ends that bring all this data together. There's an overlying software called AX Supervisory software that lets you bring in multiple sites into one networked software package. It uses, again, things like XML and SNMP. So again, drilling down to smaller levels, And providing a web-based common web portal as a front-end solution is what Tritium through JACES typically offers. The hardware level, and this is a shameless plug here, requires obviously devices that can communicate via industry standards, and examples of that we talked about, the RS-485 controllers. Examples of that are central plant controllers that are MSTP or BACnet IP capable, and unitary controllers, VAVs, package units, fan coils, the typical hardware devices you see in a building. They also need to participate in that protocol or interoperability solution in order to allow the Tritium JACES of the world to read and write their data values. So it just gives you some examples of the different layers and what components fit in those layers. Okay, now we go into a couple case studies. I got 6 brief case studies, and they're just good examples of using a whole host of interoperability solutions at multiple levels. This is Skybeam offices in Fort Collins, Colorado, done by one of our ASI resellers there, High Plains Mechanical. And the problem here was they have a incentive from the utility company. And then we're going to get into how interoperability and integration of control systems can benefit a facility by saving energy. So I believe they do have open ADR incentives here. And basically what that acronym stands for, ADR, is Automated Demand Response. And what that is if a utility provider is finding out the grid is overtaxed, they can't provide the energy they need to the various customers on the network, they have predetermined high energy users and offered incentives to those high energy users to shed X amount of kW off the grid during a certain time. So, they might have 100 clients on the network where they're going to offer some pretty substantial energy incentives at 2 o'clock on July 20th when it's 100 degrees out. We need you to get off the grid. So they give a good financial reward for doing that. So this particular office building, and again, I'm not real familiar with the local utilities, but my understanding is this is an offering that is available in the Kansas City market. So Open ADR solution was they were manually going around shutting off this equipment trying to reap these benefits from the utility company. And unfortunately, it wasn't very proficient, and it also yielded uncomfortable conditions in the building, hot in the summer, cold in the winter, because they were just shutting equipment down. They weren't doing it through a strategic, logical approach. So they looked at putting in large generators to acquire the entire load of the building and just getting 100% off the grid. And that would work, but the cost of those generators was outrageous and the payback was too long. So through the integration of a couple different industrial systems and HVAC systems, they were able to achieve the goal by putting in smaller generators and communicating. They were Generac generators, which do Modbus RTU, again an industrial protocol, not so much an HVAC protocol. But they were able to then set up shedding strategies in the rooftop units, which I believe were Trane units, and they did that through a Tritium front end and a LAN integration back when Trane did LAN. They're now switching to BACnet. And so they were able to downsize the generators to make that affordable and give shedding commands to the rooftop units through Tritium JACES to the LAN network and disable second stages or change set points, and then take some loads off and supplement that with the generators. So, it's a lot going on here, but in essence, the summary is they use system network management or simple network management protocol, which is just a network way to gather information from nodes on the network and then post alarms. They use Modbus, which again is that industrial protocol we talked about, and a traditional HVAC protocol by Echelon Corporation LAN to integrate the rooftop units. And so by strategizing this, they were able to buy smaller generators. This is a quote from the facility manager. And it basically, the retrofit of those generators and bringing those rooftops into a strategic shedding strategy, they were able to afford the project, and the return of investment was the first year almost funded the entire project. Then every supplemental year after that, the money goes back in their pocket by being able to participate in the demand response. And of course, they said having it all in one front end is really cool. So little sizzle with the steak, you get the the financial benefits, but also managing his systems was made a lot easier. There were also some carrier systems on there that they brought in through Lawn as well. So this is a typical office building. I'm sure you guys have similar scenarios here, and those incentives from the utility companies are here as well, from my understanding. This next little case study is even kind of cooler or neater. Lutron Factory in Allentown, Pennsylvania. Everybody familiar with Lutron lighting controls? They've got some really slick stuff they call quantum energy management or quantum lighting control. And it looks at external lighting. It's automated intelligent shading. So it determines the heat gain, the lighting benefit, if it can turn down internal electrical lighting and utilize outside lighting. So it's a highly intelligent system that evaluates that. Typically, it's a standalone system. So in their corporate headquarters, they wanted to have a showcase of integrating this intelligent shading system along with building automation and energy management. So again, a common protocol comes into play where we can read and write to data values in their network and influence the equipment based on the values they're seeing. So there's actually a pretty significant amount of equipment. There are 500 pieces of equipment, large office complex, utilizing the quantum shading system. And through OPC, which is again, is that industrial gateway that reads data values out of a known protocol and sends it to BACnet over IP to that front end, we're integrating both systems. And they were able to bring 9 systems in, which is the total systems on the site, and then they put a JSON to talk with some of the other low-lying internal wall sensors as well. So again, a whole host of level of integration here. And they also did a really neat mechanical concept on this, which I wanted to mention. They had quite a few large makeup air units that were constant volume that were set based on the old ASHRAE standards of like 29 CFM per person, regardless of what the occupancy was. So they converted these to CO2-based modulation makeup air units and put power meters. They did the first pilot program, so they put the power meter on the first one and saw how much energy they saved, that they went ahead and did that on all of the makeup air units. And again, using Modbus RTU to talk to. This is about a 4-year-old application. Now these intelligent electrical meters will work with BACnet and LAN, but at that time, Modbus was the only protocol they spoke. So through Modbus, they were communicating with these large makeup air units and seeing what the energy saving was in real time and doing data logging on that. So just again, another neat story about integration at various levels. These are all neat stories in case you haven't noticed by now. Okay, so cool stories. Yeah. Cool stories. Neat's old fashioned, right?
Is the lighting control similar to like what Walmart has and the skylights and the meters and shuts off the fluorescence and back on?
Very similar. I don't know if Walmart uses Lutron or not, but that obviously evaluating natural lighting versus artificial lighting is huge energy savings. As you said, they can shed those, and they do that as that one picture front end showed through shading on the windows and controlling the ballast of the lighting systems. There are a couple other competitors in that market. I'm just familiar with Lutron because fortunate enough we did their corporate headquarters. So. This is an art gallery, and this is a little twist on, again, interoperability and energy savings, but how the two go hand in hand. So this is down in Shreveport, Louisiana, and people who have been to that part of the world know that it gets hot and it gets humid down there. And actually, they do have freezing temperatures in the winter, so they got a wide temperature range there. And this is a art gallery that has a private collection, R.W. Norton, whole host of paintings, sculptures, antique guns, you name it. It's a pretty diverse collection. And their main goal was to preserve the artwork. It wasn't so much energy management or integration. So they had a lot of fluctuation in the temperatures, and as you can imagine, a picture frame, it's got the wooden frame, the canvas it's painted on, and the backing of that, and all that expands and contracts differently, absorbs moisture in a different rate. So that stress on the artwork was degrading the artwork, and they needed a more constant environment to preserve the artwork. So what they did was, our local reseller was pretty resourceful, a company called PC Automation down in Shreveport, Louisiana. They use these little hobo data loggers, and Guy and I were talking about these. They're neat little devices that you can set around a building and kind of see how the building's really operating. You know, sometimes you interview people in the building and you get their interpretation of how things are working. The neat thing about these is going to tell you temperature, humidity, CO2, whatever. There's a whole host of data values you can gather with these. So these are great little tools to assess what's really going on. And they found out that there was a huge temperature swings, even though they were controlling the constant volume systems with PID algorithms, they were still all over the place. So humidity was up and down as they approached set point. It would shut off and overshoot, and so they had a real problem there. So they came up with the solution of communicating with some of this older equipment, replacing some of it, but putting variable frequency drives on each of the blowers. And of course, VFDs, probably everybody has those in their building here, right? Pretty widely used. But they're a huge benefit to controlling a system, but it also delivers some energy savings. But again, the goal here was preservation of the artwork, not so much energy savings. And so VFDs are now widely used in the building automation and HVAC industry, but just probably 5-6 years ago, they came from the industrial world, maybe 10 years ago, and again, didn't use BACnet or LAN, which are HVAC industry protocols, but used industrial protocols such as Modbus. So what I'm painting here is a picture where you need to have all these resources to encapsulate all the intelligent systems. So through Modbus communications to the variable frequency drives, they were able to get a tighter control set point of both the humidity and the temperature and maintain a straight trend graph of humidity and temperature around the artwork. So obviously the owner was very pleased that they met his initial goal of preserving the artwork, but he was kind of surprised to see the lower energy costs that they experienced from putting VFDs on. So, and as everybody knows, and this little chart shows, you can see just cutting back the airflow to 80% saves 50% of the energy used. So VFD can, obviously control the environment, but also contribute to, quite a bit of energy savings. You can see even at 50% of the airflow, we're over 80% of the energy saved by deploying the VFD. And the value of putting the VFD and communicating to it is now your central controller that is running that air handler, or whatever the case may be, still has all the inputs and outputs available to control the equipment. So we're communicating with the VFD with Modbus and not eating up any I/O on the controller. So it makes sense to communicate with it, again, through an open protocol versus using up inputs and outputs. And of course, since they lowered their power, their demand tariffs went down as well. So this next example is another cool application. And so just defining demand, we talked about OpenADR, automated demand response. Now this is demand limiting and load shedding, another aspect in energy management control. So what we're doing here on this application is looking at spikes in how they use their energy. And a lot of you guys evaluate power bills quite often. A lot of people, not everybody, but a lot of people see that bottom right number on their power bill and they go, man, I used a lot of electricity. And that's only partly true. It's when you used it, how you used it, did you have a demand spike during a hot period of the day, and thus the name demand. So the utility company says, well, you're demanding that I provide you with X amount of kW at this point in time, so I got to charge you for that because I need the generation facilities, I need the transmission capabilities, got to have all these things in place to provide you with the demand that you're demanding. So they tattoo you with a heck of a charge for that. Your kW charge might be, 15, 18 around here, somewhere around there, and you can get up to 150% over that on demand tariffs by having that demand spike. So what we're going to do in this situation is they had a bunch of regular thermostats and people banging them on and off. They put lock boxes on, it still didn't work. So what they did was they put in an automation system that was looking at demand spikes, and I'll go into detail how that looks behind the scenes here in a minute. But basically the savings, they did one pilot program, they asked them for their worst case scenario, which was in Bronx, New York, high energy costs, high demand tariffs, and they implemented an automation system, and actually that was a low payback, the 9-month payback on that system. So return of investment in 9 months, and that prompted Safeguard to go through with 61 other facilities throughout the country. You can see the map in the center there, the corporate headquarters are in Atlanta, And so through actually static IP addresses provided by independent internet service providers, they're pulling all this data back to one web server in Atlanta, Georgia, with 61 facilities nationwide. So the savings, they implemented the project in 2009, and in 2011, when the 61 facilities were complete, their energy costs were $550,000 versus the $1.5 million of 2009. So through demand limiting and load shedding, there was significant savings. And actually our reseller, Envirotrol's group, they're out of a little small town in Maryland, they have become the default conditioned storage facility energy management group across the country. If you're in that business, you're looking for a solution, these are the guys that they call. So it's what would typically not look like a energy management profile. They've done a pretty substantial job in saving a whole host of customers in that energy or that industry quite a bit of money. Now the way it worked in there, as I mentioned, we've got a whole host of different types of equipment, intelligent power meters. And is everybody familiar with pulse count meters, where you can look at a pulse on a meter and bring that in? That gives you some of the energy profile. It lets you know what your energy usage is. But with an intelligent meter that you're communicating through with either BACnet, Modbus, or they do make them with LAN, you're getting every aspect of the energy profile. So again, you're using integration or interoperability to get more data about how the building is using its energy. For instance, you tie into the voltage, you've got the CTs, you're looking at the amp draw, so you can calculate power factor, and see how effective the power is. So there's a lot of benefit to using intelligent meters versus just pulse count meters. And of course, those intelligent meters, again, are going to be through a communication network, one of 485 bus. So we're looking at the incoming power, secondary loads, and seeing where they're at, and then implementing a threshold level of kW that the building can operate on. And anytime they're approaching that spike, they'll start shedding equipment or changing set points or whatever the customizable sequence that fits the buildings and the customer needs are. A secondary part to this is they're taking that information from those meters and doing a software front-end integration, a CSV write, a comma separated variable file right to the software, and then viewing that software via the web and initiating alarms. So this is actually a real-time screenshot of that software, a web view and web link, where one of the facility managers up in the New England area was leaving for the Thanksgiving weekend, and as he had done years before, he walked into his stairwells and overrode his electric heaters as high as they'll go because they had their water riser in there, and he didn't want them to freeze up while he was away on Thanksgiving break. And so by integrating this data into a usable format, they received alarms about this spike. They went in, viewed the web graph and saw where the spike occurred, called him up and said, "Hey, what'd you do?" So they didn't do anything. Same thing I've done for the past years, multiple years. And they were able to go back and find out where it was and then shut the breakers or shut the thermostat back, take away the manual override, and restore it back to the levels it needed to be. So it's not only, again, sharing data between systems, it's managing the building by sharing data. This is another neat example of Open ADR, and I'm going to again get a little plug here for ASI. We're very strong on backwards compatibility. A lot of companies have planned obsolescence where systems might over time be phased out. But this is the Los Angeles County Fairplex in Southern California, and they had old ASI controllers of 1996 vintage. And what they did here, again, the same thing as the earlier ADR example, they tried to manage the incentives they would receive from the utility company by manually shutting down things. They had fountains, they had lighting control, everything, and they would get the signal from the utility company to shed X amount of kW, and what they would do is go around, shut things off. Well, the problem is they didn't always meet the expectations of the utility company, so they lost the full incentive, and they also forgot to turn things back on. What happens to overrides, right? They stay permanent, and systems shut off permanently. So they did a 2014 upgrade and automated the automated demand response. So through an OpenADR client, they get a signal from the utility company to the energy management system, and then they shed the appropriate loads to meet the requirements. And then after that duration has passed, they manually reset those and turn them back on. So the first 2 months, the hottest part of the year, of course, when the fair occurs, they were able to yield up to 1.42 megawatts of savings, which was $170,000 in energy cost savings in just 2 months. So again, there's a lot of incentives. It's not always about usage. It's about when you use it and fitting into incentive programs that the utility companies have. And we also developed a mobile interface for them to help them, schedule which buildings they want to shed and which ones they want to leave on. Okay, last little case study here, and this is another interesting concept. Everybody's been to the big, multiplex movie theaters, right, where they've got a whole host of movies showing, and some of those theaters are real small and some are pretty large. So this particular chain is in the San Jose or the Bay Area. It gets warm there in the summer and a little cool in the winter. And so what they were trying to do, again, manually operate the system where they would say, okay, we got this first run major film. We're going to pre-cool this large theater, eat up a lot of energy getting it ready. It has a 500 seat capacity. We got 150 or 50 people show up. Man, we could have put them in this other theater and saved a lot of money. So what we did through, again, higher level front-end software integration known as XML Web Service, and that's Extensible Markup Language, again, another acronym. And all that means is reading data from other web services or via the internet, reading a point from this web front end and using it in the automation system. So via XML Web Services, we looked at their ticket sales and did predictive cooling of the appropriate size theater. So this first run big movie that they thought would take 500 seats only took 150. About a couple hours before, we're seeing that trend, and we cool the smaller theater. And through integrating to their system, their management system through XML, we're helping them do predictive pre-cooling or preheating of the theaters. And it gave them a pretty interesting dashboard to work with. And the comments of the facility, the chain manager was, I experienced energy savings, efficient automated system, and I didn't compromise my customer comfort. So again, win-win for everybody with integration through various levels. So that's the bulk of, or all of my presentation. I hope it was beneficial, and there was some interesting information there. I got some brochures in the back about ASI controls, and certainly if there's any questions you have on the content of our discussion, I'd like to answer those, or if there's any questions you have about ASI controls, which is a building automation control product line that these guys at DMI have used for about 9 years now. Been a good partnership. Welcome to answer those as well. But thank you for your time.
Any questions for Bill?
Hello, Bill. Thanks for coming out and speaking to us. I have a question sort of concerning the way that you get controls in the movie theaters there to sort of do predictive preparation for the rooms. Coming from like a commercial building atmosphere, my question is, we've gone to a Niagara setup, and we've also at the same time over the last year incorporated sort of changed our email, which you also use to schedule rooms. Have you seen anything where you actually would be able to use your room scheduling to predict or put rooms into standby to lower costs, either raising, lowering set points? Have you seen that, or is it always more something that you see in the way of occupancy sensors?
Okay, the question is using an automated scheduling software package to also, that just typically manages schedules but doesn't really activate the lighting or HVAC, right? So yeah, the answer is yes. We have integrated into those. The United Baptist Center in Atlanta, Georgia has a large campus, and they have a product called EMS, and it's not energy management systems, it's event management scheduling. So, and it's a SQL server, SQL Server database structures. So through ODBC, Open Database Connectivity, we read from their database when one of those meeting rooms or whatever the case may be is going occupied, and pre-cool that and then shut it off again, activate the lighting schedule, because again, overrides stay overridden. So we're pre-preparing the space and then making sure the space is turned off, and that's through that higher level software integration. So yeah, there's an easy solution for that through ODBC. Thanks for the question. Any others? All right, well, thanks again.
I've had another.
Oh, good.
There was another example where you sort of spoke about integrating VFDs into communicating with your building automation system. Just trying to do as much as I can with what I've got. I've only got one power meter in the building, but I've noticed that when I go through the VFDs, you can really get a good example or good information about KW usage at that specific VFD. I've gone through and sort of done like weekly recordings of these manually, but man, it's really time consuming. There's so many VFDs in the building. Have you seen much where you're actually writing back that information to the building automation system to say, okay, at this fan speed or at this outside air temperature, this is the type of kilowatts, this is the type of kilowatt hours that you're using?
Okay, there's a couple ways to get that information. So the power meter that you have, is it a communicating power meter, or is it just some type of pulse counter CT?
I thought it's a pulse, but it communicates with our
Okay, so it's on a twisted pair network.
I believe so.
Okay, and I know there's a little bit investment, but that's another benefit of communicating intelligent meters is you can populate more nodes on that network depending on the amount of data values you're pulling in. Do you know what protocol it's using by chance? Or
It's going to be BACnet, I believe.
BACnet. Okay, so it's an MST or IP network. Okay, well, so then it's residing on your building intranet.
Yes.
So then you can it's an investment, but each VFD you could put a meter at that low end single channel meter or 3-channel meter and give it an IP address and bring that back via BACnet IP to your front end. Okay. Would be probably the best way to do that, and then you're seeing very clearly what's going on with that drive. So, and there's other ways. There's more than one way to skin a cat, as the saying goes. But from what you have,
I think what he might have been saying is that in the VFD itself, it's got power monitoring.
what's
So
the
that data may be already
okay?
there.
What's the are you communicating with the VFDs, or are they I/O controlled? A good point.
Lance, per minute? I think it's,
They're older Cutler hammer drives. I don't know that you have anything set up for that.
So there's no power
Well,
in the VFD.
and thanks for bringing that up.
Math
Just
formula, basically the amp draw, the volt, and just displaying it in a math formula of how many kW. I don't think it's tracking it.
well, so two things that come to mind. Thanks for bringing it up, Guy. Is there's a couple things here that you could do depending on the age. Whether it's an I/O provided, and it sounds like it is. It's an older one. But if it is a VFD that you're communicating with, again, Modbus, LAN, or BACnet, that information resides in the controller. You can bring it back via that network. Or before they had that, they also had, ABB was one of the first guys, and I'm not just saying they had an embedded web server. So we talked about XML services. So you can take and stream that web data from their embedded web server into your current front end. You have a front end on the building, and read that energy usage via XML services into the front end. So it depends on like any integration, you got to say, okay, what's the age of the equipment, what's protocol it's using, what is its capabilities before you can define the method you're going to use to gather that data.
One quick question. You showed a graph of, for VFDs, the cost savings or energy savings at different frequencies. Is there also a graph for like DC ducted fan on what percentage as it goes down, what percentage you're saving?
Yeah, one of you guys were telling me you put that on your, did you put a DC motor on your home system? Mm-hmm. Yeah, so there is documentation for that, and these guys could provide it. I'm sure you consulted that before spending the money on it.
Right.
So, yeah, I don't have that with me currently, but it's, or you could Google it. Google's a resource for everything, right?